If you've been waiting for that moment when science confirms that time travel is possible, then your wait could be over. Scientists just detected something moving faster than light. And no, this isn't some new Star Trek episode. The research team consisted of more than 600 scientists from 32 different countries. They have no electric charge and they almost never interact with anything. Neutrinos are all around us at all times, and they're produced by the sun and other stars. Well, it turns out that if neutrinos were to travel faster than light, then the probabilities you get from that equation would have to be negative. They detected about 13,000 neutrinos and then traced their paths. And what they found was that the pattern was actually reversed from what they expected. Usually, the probability of one type of neutrino turning into another goes up with distance traveled. But what they saw was a dip in the probability of transformation at longer distances. And that dip gets deeper the further the neutrinos travel. There's another problem. Even if neutrinos can move faster than light, it's only under very specific circumstances. We don't know exactly what those are yet, but it likely has to do with the fact that neutrinos have masses. We think they do anyway. For a long time, scientists thought neutrinos were massless. Then in 2015, they won a Nobel Prize for proving that neutrinos can oscillate into different types. And that wouldn't be possible if they had no masses. But the masses are still unknown. We might find that all particles can travel faster than light under certain circumstances. Thanks for watching this C-Show video, or maybe only some of them can. Either way, we're living in exciting times. Now this wasn't easy because neutrinos barely interact with anything. So if they're traveling faster than light, their masses can't be zero. But if their masses aren't zero, then they can't travel at the speed of light either. One of the most popular ideas is that there's more to a neutrino than we currently understand. Physicists think it might actually be a quantum of light, or a photon. And the reason it appears to have mass is because it interacts with other particles. That makes sense of why sometimes they arrive early. They didn't actually leave late. They left on time, but we just didn't see them until later. So neutrinos are kind of stuck in the middle. Their speeds have to be greater than c, but less than something greater than c. And that creates a logical problem. In that case, they wouldn't be stuck in the middle. But personally, I think this is just a sign that we're on the verge of a scientific revolution. Think about it. For decades, physicists have been trying to account for dark matter by adding more particles to the standard model. Maybe that's unnecessary. Maybe all we need to do is change the rules for particles we already know about. And that could be a bigger deal than we realize. They passed right through the 5-meter-thick concrete walls of the accelerator, and then went through another 200 meters of Earth before being detected. That means the more massive something is, the slower it can move. So there's no way a massive particle could travel faster than light. But again, neutrinos are kind of stuck in the middle. They have mass, but they also travel faster than light, so they have to obey a different rule. After all, it's not like we're going to put a neutrino in a rocket ship anytime soon. If neutrinos do turn out to be able to travel faster than light, then that's great for advancing our understanding of physics. But it won't be any use for interstellar travel. It also wouldn't allow time travel, at least not back in time. Remember that equation we looked at earlier? If neutrinos were to travel faster than light, then the probabilities you get from that equation would have to be negative. And that could open up the possibility of traveling into the future. And because they have no electric charge, they weren't affected by the magnetic fields that the researchers used to steer other particles. So instead of magnetic fields, the researchers had to use the rising and setting of the sun to cast shadows on the detector, creating artificial eclipses to block neutrinos coming from one direction but not the other. That's the only way they could tell the neutrinos were moving in one preferred direction. And that opens up some weird possibilities. But before we get there, let's finish up the story about these MVP particles. They're created when cosmic rays hit atoms in our atmosphere. They also come from nuclear reactors and particle accelerators. since the data didn't fit with the standard model of particle physics. The authors suggest that maybe neutrinos are moving faster than light. It would also explain why sometimes they seem to arrive before the equipment has time to detect them. But it's important to remember that just because they sometimes arrive early doesn't mean they re-traveling faster than light all the time. It's like if someone told you every time you checked your phone, it said 4 o'clock. Even though sometimes you checked it and it was 3:59. So sure, your watch is wrong, but that doesn't mean it's wrong all the time. You might call them the ultimate MVPs of physics because they help explain how matter is made, how stars produce energy, and how supernova occur. Together, they worked for 9 years, analyzing data related to neutrinos. And if you don't know what a neutrino is, let me catch you up. This was reported in the prestigious journal Nature on August 9, 2022. So it must be true. Or is it? Let's take a look at what's going on here. This discovery came from an experiment called the Bell Collaboration, which was conducted by the High Energy Accelerator Research Organization in Japan. Neutrinos are elementary particles that have very little mass. The first part of this story comes down to one particular type of neutrino. It's called an electron neutrino. And we know that electron neutrinos can oscillate into other types of neutrinos as they move through space. What that means is that if you started out with a pure sample of electron neutrinos, then after a while there would also be some muon neutrinos and tau neutrinos mixed in. And the probability of that happening depends on the distance the neutrinos travel and the energy they have. We can represent that relationship with an equation, and the results of that equation will always be between 0 and 1, since probabilities have to be between those numbers. So where does faster than light come into the picture? The Bell Collaboration looked at neutrinos created by an accelerator in Japan. And after detecting these neutrinos, the researchers analyzed the data looking for the patterns that indicate the particles' changed types. And now we can finally get to the faster than light part. Plus, this isn't really faster than light, FTL travel. But don't go thinking you will be able to hop in your time machine and prevent your father from ever meeting your mother. And the thing is, if the masses were 0, then neutrinos would have to travel at the speed of light. According to Einstein's theory of special relativity, mass and energy are equivalent and they're related by the equivalent c². Physicists have proposed several ideas that would allow neutrinos to be massive and also travel faster than light. Another idea is that the standard model of particle physics is wrong and that neutrinos could be moving faster than light. Without having a mass, if that happens, it could lead to a whole new understanding of physics. And speaking of exciting things, I hope you're excited about learning something new.